We're going to take a look at graphing a system of linear inequalities, but before we do, I want to review what it meant to graph a system of equations. So I've got this system of equations here with equation A and equation B. Y equals negative 2x plus 8 and y equals 1/2 x minus 2. So to solve this system of equations by graphing, what we would do is graph each equation and find their intersection. So we would plot this first one, start up at positive 8 is the y-intercept. The slope is negative 2, so when you increase x by 1, y decreases by 2. So write 1 down 2, write 1 down 2. So we have all these points, and this is going to make up our line. So we can reverse it too, and we have this line. That's the line y equals negative 2x plus 8. Every point on this line is a solution to equation A. So take any of these points, plug in that xy pair, it'll make this first statement true. Now the second equation, our y-intercept is negative 2, so we'll plot a point there, and the slope is 1/2, so the change in y is 1, versus the change in x is 2, so when x increases by 2, y increases by 1. So write 2 up 1, write 2 up 1. And we have this line for y equals 1/2 x minus 2. Now every point that is on this line, every xy pair, substitute that into equation B, and it'll make that true. So all of these points are solutions to equation A. All of these points are solutions to equation B. And the system has one solution where we have a point that is a solution to both. So this point right here, 1, 2, 3, 4, 0, that is the solution to the system. So what it means for this point to be a solution to the system is if you substitute that xy pair, it'll work in both of the equations and be a solution to the system. So if you substitute it into the first equation, negative 2 times x is 4 plus 8 should give us 0, and it does. Substitute into the second one, 1/2 times x is 4 minus 2 should also equal 0, and it does. So that point is the solution to the system of equations. Now if we change this up, and rather than looking at equations, think of them as a system of inequalities, we're going to look at really the same sort of idea, is graphing these two inequalities and finding out where their solutions intersect. So let's make that a greater than, let's make that one a less than or equal to. So the first inequality is y is greater than negative 2x plus 8. So our y-intercept is positive 8. And the slope is negative 2, so write 1 down 2, write 1 down 2. Plot all these points. And because that is just a strictly greater than, we won't make a solid line here, we'll make a dotted line. So we'll connect all these sort of points, we'll make a dotted line. And that is saying that y is greater than 2x plus 8. So all the solutions to this are above this line. So from this line, we're going to shade everything above it. And that's going to give us this whole shaded region here. So everything, all these ordered pairs within the shaded region are solutions. Anything on this boundary line, because it's dotted, are not solutions. And in this unshaded area, those are also not solutions. If we plot the second one, we have a y-intercept of negative 2, and the slope is positive 1/2, so write 2 up 1, write 2 up 1, write 2 up 1. So plot all your points, write 1, so that's too many over, there we go. And you can reverse it back the other way, and because this is less than or equal to, we are going to use a solid line to show that points on the boundary do count as solutions. So completely ignoring the first graph that we have, we want to show our shade where the y values are less than or equal to 1/2 x minus 2. Those are all the y values that are below the line. So we're going to shade the bottom half of this graph. What's different here is that no longer do we just have two lines intersecting at one point, we have two shaded regions. So this red region here, those are all solutions to inequality A, And this blue region, those are all solutions to inequality B. For the system, what we're interested in are what's the region that shows the solutions to both, and that is where those two colors overlap. So the graph of this system of inequalities, this red region was only part of, or only solutions to A, not to both, so it's not really a solution to the whole system, so we'll get rid of that region. And this part that's just blue, those are only solutions to inequality B, so go ahead and erase that one as well, because those are not solutions to the whole system. What we're left with is this shaded region that has both colors. So this is our graph of the entire system. I want to break this down because there's a few parts of this graph that we see. If you choose a point that is within the shaded region for both, any point in there should be true. So let's take that point. That's the point 10, 0. And if you substitute that in, it'll be a solution to both of the systems. So if you look at what will this be in A, well, y is 0 is greater than negative 2 times 10 plus 8. So 0 is greater than negative 20 plus 8. So 0 is greater than negative 12. And it is. So it's a solution to the first inequality. If we take a look at that same point in our second inequality B, well, y is 0 is less than or equal to 1/2 of x is 10 minus 2. So 0 is less than or equal to 1/2 of 10 is 5, and 5 minus 2 is 3. So it is true again. That's a solution to both of the system, or both of the inequalities. So essentially what we have here is 4 regions. This region was a solution to one but not the other. That region was a solution to one but not the other. This blank region was a solution to nothing at all, and this shaded region was a solution to both. So this is what we have for our graph of the system of inequalities. Let's take a look at one more. To graph this one from the start. So we have, let's say y is less than or equal to 1/3 x minus 1. And let's say that b is going to be y is less than or equal to negative 2/3 x plus 2. So for inequality A, we're going to start at negative 1. Slope is 1/3, so that's right 3 up 1, right 3 up 1, right 3 up 1. Let's reverse that, left 3, then down 1, left 3, and down 1, left 3, down 1. And because that says less than or equal to, we'll use a solid line, solid boundary line. Now on where to shade, that says that y is less than or equal to, so we're going to shade the region that is below that line. And now graph the other one. So the other one says that y is less than or equal to negative 2/3 x plus 2. Y-intercept is up at 2. Slope is negative 2/3, so right 3 down 2, right 3 down 2, right 3 down 2, left 3 up 2, left 3 up 2. And because it's less than or equal to, that will also be a solid line. Now in relation to this line, y is less than or equal to, so we'll shade underneath it. So we'll shade everything underneath the line, just ignoring the other one for now. And we have this broken up again into 4 regions. So because these that are only one color, those are solutions to one in the system, but not both, those are not solutions to the whole system, so we'll erase those. If you're doing this with a pencil, it's a good idea to shade really lightly at first so that you can erase later on. So we'll get rid of those two, and this is the graph of our system of inequalities. These two solid boundary lines and this shaded where both shaded regions overlapped.